In this video, I'm going to show you how to solve the ALEKS problem called Understanding the Descriptive Vocabulary of Monosaccharides. There are two different versions of this problem. I'm going to show you this particular version, and I'm also going to talk about the second version of the problem. In this version, you are given a structure of 5 different monosaccharides, and it's asking you to identify each one that is an L-aldose. So there's two things that we're looking at in this name, L-aldose. I'm going to start with the aldose portion of the molecule or of the name. Aldose molecules are ones that have carbon-oxygen double bond with a hydrogen at the top of the molecular structure. So this is an aldose. This is also an aldose. This one is an aldose. These two, which have the carbon-oxygen double bond in the second carbon down, those two are called ketoses. So that is a ketose. So we know that we're not going to be checking the box of either one of these because they are ketoses. Now the other portion of the name that we're going to look at is the L. At the beginning of the name, you're either going to have the letter D or the letter L. And that letter refers to the position of the OH group on the carbon atom that is second from the bottom. So this is the bottom carbon atom, this is the second from the bottom. If the OH group is on the left-hand side, it is an L sugar. That applies to aldoses as well as ketoses. If the OH group is on the left-hand side, it is an L sugar. If the OH group is on the right-hand side, then we would call it a D sugar. So we're not going to check the box for that one. In this problem, there are 2 examples of L-aldoses. Now, it's also possible with this problem that there might be an additional prefix in the name. For example, it might say aldohexose, where hex is that added portion. It could say ketohexose. So it could have like a prefix type thing. It's kind of in the middle, so I don't know if you still call it a prefix. Could have something in the middle there as well. If you have that extra prefix in there, it is going to be referring to the total number of carbon atoms in the molecule. So if you see hex, that means 6 total carbons. If you see pent, that means 5 total carbons. If you see tetra, that means 4 total carbons. If you see tri, that means 3 total carbons. In the other version of this ALEKS problem, it doesn't give you structures. It just asks you to draw. Draw a D-aldohexose, or draw a D-ketopentose, whatever it might be. And so you're going to have the drawing tools to just kind of sketch out a structure that is going to sort of look like this. At the bottom of your molecule, you're always going to be putting CH2OH, no matter what. You want to make sure that you include the total number of carbon atoms based on whatever prefix ALEKS is giving you. So the way I'm setting this one up, it looks like I'm drawing 1, 2, 3, 4, 5, 6 total carbon atoms, or I'm going to. You are going to position a carbon-oxygen double bond either at carbon number 1 if it's an aldose, or carbon number 2 if it's a ketose. It's going to depend on the problem. I'll say I'm going to draw an aldose. You are going to fill in the location of the OH group on the second to the last carbon based on whether ALEKS tells you to draw a D or an L. If it asks you to draw a D, you're going to put the OH group on the right-hand side, not on the left. If it's an L, the OH group is going to go on the left-hand side. For the remaining parts of the molecule, you are going to put on each one of these positions an OH group on one side and an H on the other, and it's not going to matter where you put them. So you can kind of do whatever you want to do as long as each one of those horizontal bonds has one OH and one hydrogen.